The second way of combining functions is something called composition. And to give you just a quick idea of what that basically means using functions sequentially. In other words, one after the other. Let me tell you about how we write that, and then I'll show you with a function machine what that looks like. So we indicate that we're going to compose or use functions sequentially by writing f circle g. Please notice that the circle is an open circle. It's not a multiplication dot. Which would look like a little closed circle. And by the way, since I'm mentioning that, if we go back to where we defined multiplication of functions, I could have technically put a little multiplication dot in there and of course there. But we tend not to do that. So again, here I could put a multiplication dot in, but we tend not to do that because it gets confusing if you've also got this open circle, meaning composition. Okay, so what do we mean by f open circle g? Well, f composed with g of x is defined to be f of g of x. Looking at that as a function machine, what does f composed with g do if I give it some input that we'll call x? The first thing it does is g of x. Notice that x is indicated as input for g. So x goes into g, and out comes g of x. And then what happens to g of x? Well, we are using g of x as input for f, so that g of x is being fed into f. What comes out then, need a little more room here, what comes out then is f of the input, in other words, f of g of x. And so that's what comes out of our composite function. Now, I'm not really crazy about this f circle g notation, and the reason is we're so used to reading and doing things from left to right that when you see f circle g, you think you're going to use f and then g, just going left to right. That would make sense. But no, that's not what it means. It means you're going to use g first. And you can see that if you switch over to the parentheses function notation, where we're used to with parentheses working from the inside out. So working from the inside out, you have g of x first, and then you have that inputted to f. So let's see examples of how this would work. Given f of x equals x squared and g of x equals x plus 1, let's find formulas for f composed with g, g composed with f composed with f, g composed with g, and then f composed with g of 1. F composed with g of x. I never use this notation. It's just too confusing. I always immediately, if someone wants me to do this, I switch over to the normal parentheses notation where we can see what's being inputted to what. So what's being inputted to g is x. Well, what is g of x? G of x is x plus 1, and now we're using that as input for f. So we have to ask ourselves, what does f do to its input? Well, this formula tells me that any input I give to f is going to be squared. So I take that x plus 1 input and square it. This is probably another good time for a quick algebra review. Let's remember that x plus 1 squared is not equal to x squared plus 1 squared. In fact, we have a formula for x plus, let me say, y squared, namely x squared plus 2xy plus y squared. And I'll assume that you have that formula memorized. So our final answer here, if we wanted to square out the x plus 1, which we might not, but if we wanted to, our final answer would be x squared plus 2x plus 1, where the 1 is playing the role of y in the formula. And since we're doing formulas, let me remind you that there's a formula for x minus y squared, which is x squared minus 2xy plus y squared. And let me also generalize when you raise two terms, x plus y, to a power, you do not get to just put the power on the individual terms. In other words, there's no distributive property for exponents. And that's also true if you're subtracting inside the parentheses. So don't make the mistake of just distributing an exponent in across a plus or a minus. Okay, that's f composed with g. Let's do g composed with f, which means to do g of f of x. Okay, so something's being used as input for g. What is it that's being used as input for g? It's f of x. So what is f of x? F of x is x squared. And now we ask ourselves, what does g do to its inputs? Well, g takes the input and adds 1 to it. So I'll have that input x squared with a 1 added to it. Let's notice that these are not the same. In other words, f composed with g and g composed with f are not the same. So it matters what order you do these things in. Moving on to f composed with f, yes, we can compose a function with itself. That means to do f of x. So something's being used as input for f. What is being used as input for f? F of x is? What is f of x? It's x squared. Now, what does f do to any input you give it? It squares it. In other words, f takes whatever input and squares it, and our input is x squared. So we get our final answer, x to the 4th. Here's another rule of exponents I'll just quickly remind you of. X to a power raised to another power. The rule for that is you're going to multiply the powers. Let's see, what else do we have? G composed with g. So g composed with g of x is g of x. So something is being used as input for g. What is it? It's g of x. What's g of x? G of x is x plus 1. And now what does g do to any input? It takes that input and adds 1 to it. What's our input? We just said it was x plus 1. So simplifying, we get x plus 2. Last, we're asked to find f composed with g of 1. when you're putting a number in, there's two ways we can do this. So for f composed with g of 1, which means f of g of 1, I can first figure out what g of 1 is. G of 1 would be 1 plus 1, which is 2. And then what does f do to its input? It squares it, so we get 2 squared, which is 4. Or for f composed with g of 1, in other words, f of g of 1, we can use our formula for f composed with g. That was the first formula we did. The very first one. And what we got was x plus 1 squared, or x squared plus 2x plus 1, whichever you prefer. So input plus 1 and then squared. What's our input? It's this 1. So we have 2 squared again, or 4.